TCP applications offer a reliable byte stream with congestion control mechanisms, adjusting flows to current network load. Designed back in the 70s, TCP is the most widely used protocol and remains largely unchanged, unlike the network it operates within today. Back in those days, the designers understood there could be a link failure and decided to decouple the network layer IP from the transport layer TCP. This enables the routing around an IP link failure without breaking the end-to-end TCP connection. Dynamic routing protocols do this automatically without the need for transport layer knowledge. Even though it has a wide adoption, it doesn't fully align to the multipath characteristics of today's networks. TCP's main drawback is that it's a single path per connection protocol. Single path means once the stream is placed on a path which consists of an endpoint of a connection, it cannot be moved to another path even though multiple redundant paths may exist between peers. This characteristic is clearly suboptimal, as the majority of today's networks and end hosts have multipath characteristics used for better performance and robustness. The ability to use multiple paths for single TCP sessions increases resource usage and resilience. All this is achieved with additional extensions to the regular TCP, enabling the transport of connections across multiple links simultaneously. The core aim of Multipath TCP is to allow a single TCP connection to use multiple paths simultaneously by using abstractions at the transport layer. As it operates at the transport layer, the upper and lower layers are transparent to its operation. There is no network or link layer modifications needed. There is no need to make any changes to the network or the end hosts. The end hosts use the same socket API call, and the network continues to operate as before. No special configurations are required, and it's simply a capability exchange between the two end hosts. Multipath TCP is 100% backward compatible with regular TCP. Multipath TCP binds the TCP connection between two hosts, not two interfaces like regular TCP does. Regular TCP creates a connection between two IP endpoints by establishing a source destination by an IP address and port number. The application has to choose a single link for the connection. However, Multipath TCP creates a new TCP connection known as subflows, providing the ability for the application to take different links for each subflow. Subflows are set up the same as regular TCP connections. They consist of a flow of TCP segments operating over individual paths, but still part of the overall multipath connection. Subflows are never fixed, and they may fluctuate in number during the lifetime of the parent multipath TCP connection.